The lights in my room are controlled by that smart plug. The smart plug has an app for controlling it, and it has a schedule too, but I still find myself leaving my lights on when I leave. So I made this IoT smart lights controller. It has a motion detector, a microphone, and a screen. On the screen, it displays its IP address as well as a QR code that will take you to this web interface. In the web interface, you can see the status of the lights, turn them off and on, and update the status of the lights without refreshing the whole page. More importantly, you can enable and disable the three main functions of the lights. These are clapping to toggle the lights, turning the lights on when there's movement, turning the lights off after a certain period of time of no movement, and we can also change how long it takes for the lights to turn off. To toggle the lights, I can clap twice. I've now been out of my room for some time and the lights have turned off. When I enter the room, the lights turn back on. Finally, as I said earlier, the lights can be controlled through the interface. Let's take a look inside to see how it works. In the front of the housing, the microphone, the motion detector, and the screen are all held in place either by pins or connectors that hold the printed circuit boards. The brains of the operation is this ESP32. It's running MicroPython. This housing was 3D printed with this shape so that it can go into the corner of a room. The code for this project can be found on my GitHub. Let's take a look at some of the more important files. The ESP32 starts in main.py, but as we can see, there's not a lot going on here. The device is primarily controlled by the Lights Controller class. In the Lights Controller class, the microphone and motion detector are initialized. Then it connects to the Wi-Fi and initializes the lights. And then finally it starts the web server. It orchestrates most operations by passing these callbacks to its constituent classes. Next, let's check out the mic class. This works by registering an interrupt handler, which calls this callback when its sensor detects noise. It calls its own callback, but only after making sure there are two distinct claps. The motion detector works in a similar way. It registers an interrupt handler, which is activated for both motion and stillness. It then checks which case it was and responds appropriately. If stillness was detected, it starts a timer, which can be reset if motion is detected again before the motion timeout elapses. Next, let's look at how commands are sent to the lights. The Casa class sends encrypted messages over a TCP socket to the lights at the host name HS100 on the same Wi-Fi network. There are more user-friendly methods like toggle, off, and on. The main thread spends its time in a loop in the server class. Essentially, the device tries to listen to connections on port 80 and sends the user interface HTML for each connection. And those are the most important components of the code. Thanks for watching.